So sometimes it's better just to walk through some of these as a video. Okay, so that's what I'm going to try to do here. Let me see if I can get this. Let's see. Thickness, that's what I want. Okay, so this is one of those problems from the from the study forge materials. Hope you're finding those. If not, you should get a hold. Let me know, and we'll get VTVLC and on getting you access to these. So this is one of the homework exercises you were supposed to have done. So what's happening here? Cosine of x. Well, if you remember from your work in pre-calc, if I set one, of course, when I'm finding a limit, I substitute in the values, right? So the cosine of 0 is 1, and of course it's 0, and that's undefined, of course, because we can't divide by 0. But what we're trying to do is we're actually trying to find a limit. So we're approaching 0. We're approaching 0. So on the numerator, the code is like, so let's say x is, I don't know, it's a number like 0.001. Well, if I substitute in the cosine of 0.001, that's going to be a pretty small number, right? It's going to be approaching 1, because we know the cosine of 0 is 1. So we know it's getting close to 1. What it is exactly, I know it's not exact 1, but it's close to it. And then if I'm substituting in 0.001 for x, that's the same as 1 over 1,000. Well, 1 divided by 1 over 1,000 is the same as 1 times 1,000. So that's going to infinity is where that's headed. So that's why in this situation, they're saying it doesn't exist. And of course, because this is kind of like the reciprocal function squared. The reciprocal function. If you think about cosine x over cosine, that's the same as cosine, or 1 over x times cosine. And that's just a reciprocal function with heads in opposite directions as you approach 0. And this is approaching 1. So this is why they're saying it doesn't exist, because as you approach it from the left, it goes to negative infinity. As you approach it from the right, it goes to positive infinity. Not the same value. But it's going to infinity. So either way, it doesn't exist. It's just sometimes they talk about it differently. Okay, so that's that problem. Now, what about this one where they're throwing more at us? Well, let's see. Let me get an eraser going here and clean up some of this. We're going to use that fact. The reason I pointed out that problem is because we're going to use that fact to evaluate this limit. And I'm seeing a sum, a difference. So when I'm evaluating limits here, let me make that be narrower ink. When I'm evaluating limits, I can break it up into the separate pieces. So the limit as x approaches 0 of 1. And then if I've got a constant multiple, I can always bring that out. I can say minus the limit of cosine squared x over x as x approaches 0. And of course, with this piece here, as x approaches 0, this is always 1. So we don't have to worry about that. Now, as you go look at this piece, this is going to be, I can think cosine squared x over x as cosine x over x times cosine x. And then as x goes to 0, we just decided here that, and of course we can break this out to the limit as x approaches 0 here and the limit as x approaches 0 here. So we're multiplying those two limits, and we already decided this goes to infinity or doesn't exist, right? And this one will be as close, that'll be 1. So if I have 1 minus infinity times 1, 1 minus infinity is still a huge number. So it doesn't exist. And of course, as you go from different sides, it just goes to negative infinity, positive infinity. Either case, there's no limit. So that's why they said that doesn't exist. I don't know if that's the way you did it or if you were just guessing, but that's how I would tackle that. Okay, so here's another study forge question on the left, and so this is asking me to find that limit, and of course, as we've talked about, if you substitute in trying to find a limit, you want to do the direct substitution first. So here, how do I get rid of this here? It's different. Okay, come on, get out of there. Okay, that, right click, there we go. So if I substitute in 3, I get 3 minus 3 over 9 minus 9, which is 0 over 0. So that tells me this is there's a hole in the graph here, right? So how we take care of this is we try to remove that hole. So the denominator is the difference of 2 squares, and that factors to n plus 3 times n minus 3. And then we notice we have a common factor of n minus 3, so I can remove that. And then what I'm doing is I'm taking the limit as x approaches 3, but we remember really what we're doing is we're making the promise that we won't ever get to 3, because as soon as we get x equals 3, it's undefined. But here's the new limit. So as x approaches 3, we're going to get 1 over 6. And that's how we remove that. So when you substitute in a value and you get 0 over 0, you got to try to remove that hole. We remove the part of it that's giving you 0. So that's what's happening here, right? If we substitute in 2, we get 4 minus 4 over 2 minus 2, which is 0 over 0. Needs more work. And you always want to make sure this happens, that you just don't automatically look at it, because it may be a situation where it's an infinite limit. And so we got to make sure we check. So let's see, can I do this erase what I just wrote here? And then I'm gonna put a pen, thin stuff, and then I'm gonna tip on it. Whoops, pen, yeah, okay, what am I trying to do? Try and do that. No, I want that, and then I'm gonna click on that. There. So what I'm gonna try to do is I don't have a pen anymore. There. Well, I've got 0 over 0, we said. So the numerator, hope you see, it factors to what's happening here. It factors to x plus 2 times x minus 2 all over x minus 2, and then we can remove that where the hole's coming from. So then what's the limit as x approaches 2? And what's left is the x plus 2. Well, if you drop in the 2, 2 plus 2 is 4, and that's where that 4 came from. Okay, so make sure you get this down. Very important idea for the next section, or the next module when we start looking at derivatives. And for this last one here, let me try to zoom in so you can see it better, though you already know what it is. See how that's the exact same thing as the problem I just did. If you drop in 5, it's get 0 over 0. So then you factor the numerator, try to cancel out the x minus 5. I won't take any more video time for that, because that's the same kind of question. Okay, so I guess that answers your questions. Hope that answers your questions. Make sure you can gain access to the StudyForge materials here. If I'm in Canvas, what I'm doing is, let's see, maybe I should switch myself to a student view. Hold on a minute here. Let me stop the recording and I'll come back. Okay, so I'm in student view, so it thinks I'm a student, and it thinks to me I'm a new student in the system, and I just got an error that I want to make sure that you're not getting. So I scroll down to module 2, and you see this introduction to limit videos. If I click on that, I get to the StudyForge page, and see how I'm getting the error occurred. If this is happening for you, you need to email. You can email me or email Hannah Farnham, and they got to pay for you to have access to this, because that's part of the course, and that's what you paid for. Okay, so what I'm going to do is leave student view. Let me come back, click here, and it'll probably let me do it. And then this opens up, and you get some notes you can print, and then you got all these questions. These are like your homework questions out of your book, and you really want to do them. I think you can print them so that you can do them offline, but you really want to do these questions, because this is where you're learning the material. And those little quizzes that Florida Virtual School puts on, those aren't enough. Those are just like a quick measure, quick snapshot. You want to do this practice, okay? And this is part of the course, so you shouldn't have to pay anything more for this. At least that's what I'm to understand. So hopefully this will help you, and give me a yell if you need some help. And if you don't want to meet on Saturday, give me a yell and I'll cancel that appointment.